In this video, we'll talk about how waves erode the shoreline and create sediment, and how they transport and eventually deposit that sediment along the shore as well. Not every shoreline erodes at the same rate or in the same ways as other shorelines. And there are a lot of different things that can affect to what degree a shoreline is eroded. One of the things will be how close it is to rivers that are carrying a lot of sediment. With a river carrying a lot of sediment, it's going to be able to erode that coastline more than if there wasn't a river nearby or if it didn't have much sediment in that river. It also depends on the amount of tectonic activity. If we have more tectonics, the ground itself will be moving and breaking down more, leading to more erosion than if we had no plate tectonics occurring. But the shape and the type of the land is also important. We'll see that really flat shorelines, like in Florida, are eroded more easily than really steep shorelines, like California. And that rocks like limestone, which makes up Florida, are also easily eroded compared to rocks like granite, which make up Georgia. But we'll also see that different types of weather and wind patterns can affect how much a shoreline's eroded, as well as the overall shape of that coastline. As our waves are moving through and breaking across our shoreline, it can cause some erosional features to develop. We'll see other features on our next slide that are depositional, that happen when we deposit sediment. But on this slide, we're looking at erosional features, the ones that are being weathered and eroded away. So on the left, on this first image, we're looking at a wave-cut cliff. The waves have come through, and over time, they have broken the rocks into a cliff face, a nearly vertical stack of rocks that look like they're just kind of on the edge of the ocean. Beneath that, we're looking at a photo of a wave-cut platform. This is where waves have previously been on top of this area, and they've cut a nice flat platform, kind of like a stage, into the bottom of these rocks. If we have multiple wave-cut platforms stacked near each other, it can create a marine terrace. It's going to be these wave-cut platforms, but it's going to look like it's a series of stairs instead of just one overall flat platform. But here on the right, we're looking at an image of a sea stack and sea arches. And these are associated with headlands. This is an area of our coast that's kind of jutting out into the water a little bit. So it's not a straight coastline. It has some kind of formation that's moving out into the ocean. And with this, the waves are going to be able to erode those rocks that are jutting out into the water. And it can create a sea stack, which is just going to be a stack of rocks by themselves in the water, or it can create sea arches. The waves can erode away arch waves, kind of like hallways into the rock, leading to these sea arches. But everything on this slide is an erosional feature, where the waves are eroding the sediment and rocks along the shoreline. This slide deals with depositional features, where the shoreline is starting to deposit some of that eroded sediment. And it can lead to very different features. One of these is going to be a spit. This is where we have sand that's extending and kind of ending in a hook-like shape. If we look at this zoomed-in photograph of Provincetown in Massachusetts, it is a spit. It's just a large area of loose sand that's being carried by those longshore currents and being deposited. We can also have a bay mouth bar that develops. And this is very similar to a spit, but instead of just moving out into the ocean, a bay mouth bar is going to be able to completely cover the bay. It's going to go from one side of the land to another, whereas the spit's only connected to the land on one side. The other one ends in that hook. The bay mouth bar, on the other hand, is connected to land on both sides, completely cutting off the bay behind it. And then our final depositional feature for this slide is called a tombolo. And this is another type of ridge of sand where we're going to be able to connect one island to another. Our last depositional feature on a shoreline is super common around Florida, and these are barrier islands. These we're going to find all around the Atlantic and the Gulf Coast of America. And these are going to be long ridges of sand that are parallel to the coastline. But these are not actually on solid rock. It is just all loose sand. But these barrier islands are going to form in 3 different ways. The first is that it was a spit that was broken up into several pieces and cut off from the mainland. The second is when we had really turbulent waters, like during a hurricane, that would scoop up sand from the bottom of the ocean and push it closer to the coastline, leaving this long ridge of sand behind. And the third way formed during our last glacial maximum. That period 20,000 years ago when there was a whole lot of ice on our planet and sea levels dropped. This could have formed sand dunes along the edges of our coastlines. We'll see that our coastline evolves very slowly but constantly over time. And this image is showing us as we progress from current into, let's say, the future, but as this shoreline progresses through time. Starting with the first at the top, we have 2 narrow bays that are cutting into a very irregularly shaped coastline. Here, a rocky peninsula is going to be jutting out into the ocean, and water's flowing through that sea arch in the peninsula. Also note this small island that's sitting off the coast. Moving into the second part of this image, this same coastline is looking very different after a little bit of time has passed. A thin strip of land called a tombolo is now connecting that small island to the mainland. A spit also extends part of the way across one of those bays, and where the sea arch was, a sea stack now extends from the ocean offshore of a really steep wave-cut cliff. And going to the third part, after even more time has passed, we see that the shoreline is now more or less straight and resembles a wave-cut platform. Wave-cut cliffs line the coast with beach deposits sitting below it. And a baymouth bar isolates one of the narrow bays from the ocean, while a spit extends partway across the other bay. And a longshore current runs in one direction across the coast.